Hi everyone, my name is Sarah Berger and I'm Sales Manager at the Terminal Distribution Center Logistics Division at Inform. And today I'd like to share how artificial intelligence and mathematical optimization can help to improve train loading and network planning in combined transport. In this presentation, I will talk about the key outcomes from our latest research project, which is called KIBA. And this was led by Verkehr and carried out together with several partners like the DUS, Goethe University Frankfurt, Consult, the Technical University of Darmstadt, and VTG. One second. So I would like to start with the basic scenario that I assume all combined transport operators are familiar with. The allocation of a book load unit to one or multiple train trips with the fastest routing on a suitable wagon slot. And I assume that we are all on the same page that we are talking about a highly dynamic and complex environment. And this maybe sounds easier than it actually is. And when we take a closer look behind the scenes, intermodal transport in general is anything but simple. There are many routes, terminals, operators involved, that even small changes in one place can easily affect the whole supply chain. And on top of that, there's constant market pressure in terms of making rail freight more attractive than road transport, for example. Additionally, demand is also volatile. Bookings can change at short notice and priorities quickly shift. And at the same time, capacity limits like train length, wagon availability, and yard space put additional constraints on accurate planning. Processes that are handled manually often lead to inefficiencies and human errors, especially when unpredictable events show up, like disruptions or congestions, and makes planning even harder for humans. And of course, all of this increases the risk of safety issues. This starts at incorrect loading to overloads and other things that can happen. So overall, I think that we are all at the same page, that we operate in a highly dynamic environment where making the most suitable decision is really a challenge for humans. And for this reason, we decided to combine artificial intelligence and mathematical algorithms to support transport operators. And within the KIBA project, the focus was on two main areas. The first one is the optimization of network planning, and the second, the optimization of train loading. And these solutions were developed with one common goal: to use the existing resources more efficiently and to reduce the manual effort in daily operations. Before I dive deeper into the project itself, I would like to explain the role info played in this project. So just a few words for those who might not know us yet. We are based in Aachen, in Germany, next to the Dutch and Belgian border, and we've been working on AI-based software solutions for more than 5 decades now. Today, we have 7 subsidiaries on 4 continents, to help our clients internationally to improve their operational efficiency. And besides that, Inform consists of several divisions. One of them is my Terminal Distribution Center Logistics Division, and we've been collaborating with maritime and intermodal terminal operators for many years now to help them optimize their operations and workflows. And with the KIBA project, we used our expertise the first time outside of the terminal walls. So now I would like to take a closer look at the first focus area, the optimization of network planning, which determines which train journeys a load unit takes from its starting point to its destination. So why is network optimization important? when we talk about network optimization, the idea is to move from isolated planning towards a data-driven system that uses the available network capacity in the best possible way. It's about distributing load units smartly across the European rail network so we can move more containers with the same infrastructure. And by doing that, we reduce congestion and rehandlings at terminals and make rail transport faster and more cost efficient as well. And with the support of AI, we are able to predict better and plan in real time, to operate more resiliently and even if disruptions show up. And yeah, how does this work? So the idea behind optimized network planning is to combine forecasting and optimization into one continuous process. The first step is machine learning analyzes historical booking data and identifies customer behavior patterns. And based on these patterns, future bookings that are likely to occur in the near term will be created. These forecasts include information such as the load unit's weight, the size, types, as well as the expected weekday and the origin-destination relation. In the second step, the booking forecasts are combined with the confirmed bookings from the combined transport operator. And based on this, each load unit is assigned to a specific train journey. During this process, several operational constraints are taken into account, such as maximum train length, the total train weight, trains that are serving multiple relations, and specific route profiles as well. The system also ensures that the earliest possible departure and the required delivery deadline at the destination terminal are both respected. So the result is a dynamic, data-driven network planning that continuously updates as new information is available. I would like to introduce two cases where the optimization of network planning becomes really valuable. One is no human keep track of bookings, routes, and restrictions in real time. This is even not possible. The software can, and it can even predict future demand. And the second is in case of disruptions or new bookings. That means, for example, if a train track is closed and the load unit have to be booked on another train journey or additional load units are booked at short notice, the optimizer will be triggered to re-optimize based on the new information, ensuring that the network remains balanced and resources are used efficiently. Now that I've explained how the optimization of network planning works, I will now introduce you to the optimized planning of train loading, which provides the answer to the question where to put a load unit on a train. So why is train load optimization important? Because loading a train manually is complex. There are many factors and operational constraints to consider. The optimization helps planners make these decisions quickly and consistently by a push of a button. It assigns each load unit to a suitable wagon. It keeps handling time slow by reducing crane travel distances and handlings under consideration of safety regulations and the avoidance of rehandling load units. So in the end, the goal is to maximize the number of planned load units while keeping the operational effort in the terminal as low as possible. So the next question is, how does this work? Again, the optimizer takes into account relevant data like booking data, wagon master data, train route information like destinations and route profiles, as well as restrictions and maximum weights. Also, hazardous goods regulations or compatibility rules to create an optimized train load plan. This plan will be adjusted dynamically whenever there are disruptions or load units captured in the system. When does the solution bring value to your operations? I would like to explain 3 main scenarios that are probably very familiar to you. One could be a high priority load unit might arrive at the terminal on short notice by truck, and this load unit has to be loaded on a suitable wagon while loading already started. Another situation could be when the actual wagon setup on site differs from what was communicated from the operator. Therefore, the system can instantly re-optimize the loading plan. And the third one could be a company operates several terminals, and usually each terminal has its own train load planner. And by using this tool, it's possible to centralize the train load planning across all sites. So to sum things up, both solutions help terminal operators and rail operators to get more out of what they already have by moving more cargo with the same resources while keeping operations stable and predictable. They support smarter planning, reducing unnecessary waiting times and costs, and make schedules more reliable for customers, which leads to a higher service level at the end. So in the bigger picture, it levels up the competitiveness of rail freight by offering a more consistent, efficient, and attractive service. Yeah, so thanks for your attention. Feel free to reach out to me if there are any questions. I'm also happy to enter your network, so also feel free to add me on LinkedIn as well.
So thanks, Sarah. I think again you have applause from the audience. It's quite impressive if the intermodal world can somehow integrate the network capacity, because for the moment there's a lot of, I think, ongoing discussion on how can we improve the capacity or the scarce capacity on the railway side. It would be a very interesting role if the intermodal operators and terminals could have a major role, I think, in that. And certainly, I think by using your optimizing modules, I think would be a great interest. I know the topic for now for the 25 years about load optimization. What is quite impressive, I think, if you manage that, you need, of course, to have all this. This is why certainly VTG was on board to have all this loading capabilities per wagon types and so on, because there are a lot of different wagons and different loading schemes that exist in Europe. So that's certainly, I think, one of the challenge that you have is to collect the data. We are coming back to the data. You need high qualitative data, I think, in order to be able, I think, to improve certainly that. I would have one question, because you said that's a project, meaning now it's going to be in production, or the companies are still thinking about the decision, I think, on how to proceed. Yeah, that's still maybe an open question that I would have. Yeah.
Yeah, so this solution is not live yet, but we are happy to get pilot customers, of course. Yeah.
Okay, but that's a product that exists, that has been...
it's a prototype is existing, exactly, okay. But it's not live yet.
Okay. I'm just asking that because we have launched a project called Bridge, where we have to digitalize door to door. There's one specific activities on terminals, and that could be one interesting topic that we could discuss with you. Yeah. Okay, thanks a lot.
You're welcome.
Sorry, because just there was something in there's one question. Okay, one of our the technical coordinator of Bridge. Do you have a quantitative estimate for savings or productivity?
Good question. I think I can answer this question after I talk to our technical guys. I have no numbers yet here that I can provide, but reach out to me and I will answer your questions, of course. Yeah.